Hello, my name is Juan Prado, and I am from Practical Laboratory Section 102 of Water Treatment course. Our course project was focused on the valorization of swine digestate through the production of biochar for contaminant removal from water. Swine digestate is the residual material obtained after the anaerobic digestion of pig waste. Normally, this material can be used as fertilizer, but its continuous application can cause the accumulation of nutrients in the soil. For this reason, our project looked for an alternative that could keep this residue and a higher add value. During the project, we compared different alternatives, including biochar, briquettes, and paving blocks. Finally, biochar was selected as the most suitable alternative because it allowed us to valorize the digestate and at the same time obtain a material with a possible application in water treatment. The process consists in combining the swine digestate with gas conditioning the material through drying and side reduction, and then transforming it through pyrolysis. The material was treated at approximately 50, 550 degrees Celsius for 1 hour under a nitrogen atmosphere. The final product was biochar. During the development of the project, several laboratory analyses were performed before and after biochar the biochar. The first analysis was moisture determination. In this analysis is in the digest state. Percent at 45.44% moisture. This result was important because it showed that the material required a drying stage before pyrolysis. Reducing the moisture helps prepare the digest state for a more efficient thermal treatment. The second analysis was the determination of volatile solids and ash. Digest state contained 73% volatile solids and 26% ash. This analysis helped us understand the composition of the raw material. The volatile solids represent an important organic fraction that could be transferred during pyrolysis, while the ash represent the mineral fraction that could remain in the solution. The three important analyses were the absorption test because it allowed us to evaluate to the final application of the science. If we test the material with oxytetracycline and acetic acid in water. For oxytetracycline, the average removal efficiency was 76%, while for acetic acid was 65%. The results show what the biochar produced from the digestate and rice husk was able to reduce the concentration of blood compounds under experimental conditions. Through this project, I learned the importance of characterizing a waste before selecting a treatment technology. I also learned how a thermochemical process such as pyrolysis can transform an hereditary residue into a new material and how absorption can be used for contaminants from water. From a sustainability perspective, this project is important because it combines waste management and water treatment, instead of considering swine digestate and rice hulls only as residues. They can be used as a raw materials to produce biochar with a potential environmental application. In this way, the project contributes to the principles of circular economy because of waste material is transformed into a new product with added value. At the same time, it offers a possible alternative for reducing contaminants in water. In conclusion, the project showed that the swine system can have application, its traditional use of fertilizer, and can be transformed into material with potential use in water treatment. Thank you so much.